Hi everyone, in this video I'll be talking about midterm question 9. Question we're given that the average monthly household income in Singapore is 9618 and the standard deviation is 526. So we can write it down. However, we're not told any other assumptions of the distribution, so we should not assume any other particular distribution. So let's take a look at part A in more detail. Part A tells us that 75% of households earn between A and B, where A is the mean, minus K times the standard deviation, and B is the mean plus a constant times the standard deviation. Right, so we want to find the value of K. Here we are told that there's no additional assumptions, right? So this is very important for this question. And the only part in the lecture that gives a bound without any other assumption is the Chebyshev's theorem. So I hope you remember what the Chebyshev's theorem says. So let me just go into it in a bit more detail. The theorem states that as long as K is more than 1, the share of observations that fall within K standard deviations to the mean, given by this interval over here, is at least 100 times 1 minus 1 over K squared. So if I just draw a PDF, this distribution over here is not the normal distribution. It has very fat tails. But given a value of K, I can bound a particular area, for example something like this, and we know that the area under here is at least 1 minus 1 over K squared, right? So it can be greater than, but it's definitely not less than this value of 1 minus 1 over K squared. So using this information, we can now try to solve. So 75%, this means that 75 equals 100 times 1 minus 1 over K squared, and we solve for the value of K. So this is just some algebraic manipulation. We get K squared equals to 4. Take the square root, K equals to 2. We reject the K equals to minus 2 solution. So we have the value of the mean 9618, the standard deviation 526, and the value of K. We can now solve for the value of A and B. Just plug in the values. We get A equals to 9618 minus 2 times 526 equals to 8566. And doing likewise, we can find that the value of B equals to 10670. Okay, so this concludes part A of the question. Now let's take a look at part B. In part B, we are now told that there's a distribution assumption of normality. The researcher assumes the normal distribution, and we want to find the new estimates of A and B. Okay, so the normal distribution looks something like this, alright? And we are told that given a value of 0.75, right, we want to find the value of K such that this is 0.75. We want to find the value of K such that the area between minus K and K is 0.75. In other words, 75% of the average monthly household income should fall within this boundary of minus K and K. Right, but this is a standard normal distribution, and we need to convert it back to the normal distribution given by the particular values here. Okay, so let's solve for the standard normal distribution first. We know that Z is bounded between minus K and K, and we know that this value can be translated to probability Z less than K minus probability Z less than minus K. So let me just draw a simple PDF to illustrate here. So given a standard normal distribution, we know that the value that it lies between minus K and K, right? So you want to find probability Z minus K minus probability Z less than minus K, right? This is simply the shaded area, right? That's simply the shaded area minus the area where it's a vertical lines. Okay, so the intersection is probability less than Z minus K, and you can see the area is the same as the first one, probability that Z is between minus K and K. So now let's since the standard normal table, the CDF table only gives us the value when Z is more than 0, with K more than 0 I mean. So we have to convert it to probability Z more than K, and this is simply probability 1 minus probability Z less than K, and we group them together, we get 2 times probability Z less than K minus 1 equals 0.75. So this is simply probability Z less than K equals 0.875, and so K equals 1.15. Okay, and now we have to find the bounds. And for this part, since we have to find the bounds, this will come in useful. We know that Z equals to K minus mu over sigma. This is simply the standardization formula. So we know mu and we know sigma. We can just plug in the values of sigma to find the values of A and B respectively. Alright, so we find the value of A is 9013.1 and the value of B is 10222.9. Okay, and so this means that 75% of the observations, if you assume a normal distribution, will fall between these two values. Okay, and that's the end of question 9.